This lesson is rational expressions. A rational number can be written as the quotient of two integers. These are some examples. A rational expression is an expression that can be written as the quotient of two polynomials. Here's an example. A rational equation is an equation with only rational expressions on both sides. We can argue that 10 is a rational expression because it can be written as 10 over 1. In this example, we're going to multiply these two rational expressions. In order to do that, we're going to factor everything first. So the x squared plus 2x minus 3 factors to x minus 3 times x minus 1. The 3x plus 12 factors to 3 times x plus 4. And the x squared plus 8x plus 16 factors to x plus 4 squared. The next thing we want to do is reduce common factors. So there's an x minus 1 in the numerator and denominator, so we'll reduce those. And we have an x plus 4 in the numerator and denominator. We'll reduce those. Then we'll just write down the factors that are left. And that's where we're going to stop. We don't want to distribute that 3, because if we leave it in this form, anybody that looks at it can see that everything is reduced. Here's another example. We're going to do a division this time. Remember, to divide by a fraction, the rule is to invert and multiply. So we're inverting the second fraction. X squared plus 5x plus 6 goes to the top. X squared minus 3x minus 4 goes to the denominator. And we'll go ahead and multiply. Again, we're going to factor everything we can. X minus 4 doesn't do anything, but x squared plus 5x plus 6 factors. And so do the other two terms, other two expressions. We'll look for common factors to reduce. And when we're done reducing, we'll write down the factors that are left. So in the numerator, we have left an x plus 3. And the denominator will have an x minus 2 and an x plus 1. Again, we don't want to multiply this out, because then we won't be able to just look at it and tell that it's reduced all the way. If we leave it in factored form, anybody should be able to look at it and tell that it's reduced. In this example, we're going to simplify, but we're also going to state restrictions on the variable. In other words, what can x not be? So let's factor the numerator. We can take out a 2 and factor the denominator. We can reduce the x plus 5s, and we're left with 2 over x plus 5. But x could never be negative 5. That would cause a division by 0. And you actually want to look for that back up here, because anything that would cause this thing to be 0 would cause this whole thing to be undefined. Here's one for you to try. Simplify and state any restrictions. Pause the video right here. When you're ready to check your answer, press play. All right, so what I would do is I can't do anything with the numerator, so I'll just leave it alone. I've got a 2x. The denominator, I can take out a 2x. The result is, what, 2x minus 1? And then I can reduce these two x's. So my answer here is going to be 1 over 2x minus 1. My restriction is x can never be 0 or 1/2. If x is 0, it causes this denominator to be 0. I can see that right here. If x is 1/2, it causes this denominator to be 1/2. I can see that right here. So I'll never allow x to be 0 or 1/2, so that my denominator is always defined under division, or my expression is always defined under division. How'd you do? Here's another one for you to try. Okay, let's see. I would factor the numerator. I've got a difference of squares, so that's going to be an x plus 7 and an x minus 7. The denominator is still x plus 7. The x plus 7s will reduce out and leaves only the x minus 7. But we do have a restriction on x. X could never be negative 7. If x is negative 7, this thing doesn't make sense to divide by that 0. So we have to make sure that x is never negative 7. How'd you do? Here's another one. Well, on this one, there's nothing to factor, but there's plenty to reduce. Let's reduce the 2 and the 10. That'll give me a 5. Let's reduce the 5 and the 5. Is there anything else I can reduce? Sure, there's variables. I've got 3 x's here, I can take out 3 x's here. I've got 2 y's here, I can take out 2 y's here. Let's see what's left. I have this all went to x, this went to y. So I have xy over, where is it, 4? And then restrictions, well, x cannot be 0 and y cannot be 0. If x or y is 0, then these denominators don't make sense under division. So we're going to go ahead and say they can't be 0. We're done. Here's another one for you to try. Let's see, we've got a lot of factoring to do here. I'm going to start where the easy stuff is. This bottom one is just x plus 2, x minus 2. This one I need two numbers whose product is 6 and whose sum is 5. That should work with -2 and -3. Here, looks like 2 and 1 will get me a 3, x plus 2, x plus 1. And down here, 3 minus 1 would give me that -2. So x, let's see, I need a -3, -3, and +1. Let's keep this connected. So just a quick double check here, x squared, that'll give me a -2 and a -3. Yep, I'm good. So now let's start reducing. X minus 2 can go out, x minus 3 can go out, x plus 2 can go out, and x plus, oh man, everything just reduced out, so our final answer here is 1. But we do have restrictions. X can never be -1, it can never be positive or -2, and it can never be 3. Why? Well, if x is any of these values, it would make any of these factors 0. And if any of these factors is 0, then we're dividing by 0, and that's undefined. So our answer is 1 with these restrictions on x. How'd you do? Here's another one for you to try. You're dividing this time. Okay. The rule for division is just to invert and multiply. So let's do that. We're going to change this to multiplication. And I'll factor on the fly here. On this numerator, I can take out a 3. That leaves me a y minus 4. The denominator I can't do anything with, so we'll just write it down. The denominator here is going to come to the numerator here. And I can take out a 4. Gives me a y plus 2. And the numerator here is going to come down. I can take out a 6 and gives me a y minus 4. So there's a few things I can reduce here. I can reduce the y minus 4, so they're out. I can reduce a 3 and the 6, knocks it down to a 2. And I can reduce now the 2 and the 4, knocks it down to a 2. So let's see what's left. I have a 2 times y plus 2 in the numerator, and I have a y cubed in the denominator. Restrictions? Well, y could never be 0. That would cause a problem here. Or 4. That would cause a problem here. So here's our final answer. How'd you do? Here's another one for you to try. Go ahead and pause the video. All right, here we go. We've got division again, so we're going to change that to multiplication. We'll keep the x squared. We'll factor x squared plus 2x plus 1. That's just x plus 1 quantity squared. X squared minus 1 factors to x plus 1, x minus 1. And 3x won't do anything. Let's reduce what we can. One of these x plus 1s will go out with that one. This x will go out with one of these. Let's see what's left. We have an x times x minus 1 in the numerator, and we have a 3 times x plus 1 in the denominator. Our restrictions, well, x can never be 0 for here and -1 for there. 0 and -1. And we're good. How'd you do? All right, so here we go. We're going to go ahead and change this to multiplication. Sorry about that bell in the background. We're going to factor. We've got x plus 5 and x minus 5. We've got the bottom is already x plus 5 squared. This 4x plus 20 is going to go to the numerator, but we're going to take out a 4 in the process. And this 2x plus 10 is going to go to the denominator. We're going to take out a 2 in the process. So let's see what we can reduce here. These 2x plus 5s will definitely go out with these 2x plus 5s. So let's just take all those. And then we have the 2 can reduce with the 4. And the result here is 2 times x minus 5 in the numerator and 2 times, I don't have a 2 anymore, just x plus 5 in the denominator. My restrictions are x can never be negative 5. That's the only thing I got in the denominator. So we're done right there. How'd you do? Let's go ahead and say that's our learning target, and I'll see you in class.